Welcome to the WION podcast, where we explore fascinating stories and ideas from various fields. In this episode, we uncover how scientists drilled 4,160 feet into Earth's mantle and discovered remarkable evidence that may rewrite theories about the beginning of life on Earth. Hidden beneath miles of ocean and rock lies a world that still holds some of Earth's oldest unanswered mysteries. This section of rocks is a data mine that helps us understand how things work inside our planet. The achievement is also expected to offer a peek into the origin of life, volcanic activities, and how elements like carbon and hydrogen move between the ocean, rocks, and Earth's deep interior. The mantle makes up 80% of our planet's volume, with a thick outer crust. Below the mantle is the outer core that consists of liquid metal. This mix of iron and nickel swirls to give us our magnetic field. In the innermost part is the inner core, which is solid. Professor Johan Lissenberg from Cardiff University's School of Earth and Environmental Sciences conducted the work in 2023. The area chosen was the seabed near the Mid-Atlantic Ridge because in this underwater area, the crust is thin, allowing mantle rocks to sit closer to the surface. Previous attempts to drill into the crust and reach the mantle reached a depth of only 650 feet, but Lissenberg and his team managed to drill deeper and extract a continuous piece measuring 4,160 feet. Our study begins to look at the composition of the mantle by documenting the mineralogy of the recovered rocks, as well as their chemical makeup, he said. The team found that the mantle had undergone more melting than previously believed, which explains the formation of magma and volcanic eruptions. They also observed pathways in the rocks used by magma to swell up to the Earth's surface, explaining how it moves upwards. This is important because it tells us how the mantle melts and feeds volcanoes, particularly those on the ocean floor that account for the majority of volcanism on Earth, explains Professor Lissenberg. Scientists also noted that the rocks contain an abundant mineral called olivine. When olivine comes into direct contact with hot seawater, it undergoes a chemical reaction known as serpentinization. It gives scientists a real-world model to study the conditions that may have supported the very first forms of life on early Earth. Researchers believe this process served as the necessary spark that generated organic building blocks before life officially began. The sample will act as a baseline reference for geologists, microbiologists, and geochemists for decades to come. Thanks for tuning into this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.